Good day, student. We carry on with our lessons. You'll find the links on YouTube. I'll share the links with you. And today we carry on with operational amplifiers. So far we've covered two configurations. We have covered the inverting amplifier configuration. In which case we had studied that the input signal is applied to the inverting or negative input of the operational amplifier. And with the inverting amplifier, we had the non-inverting input, which is the positive side, to be grounded. And then we had the input signal applied through an input resistance Ri, which serves as a current limiting resistor. We had it applied on the inverting input of the amplifier. That's why we call it inverting amplifier configuration. And we had a feedback resistor Rf connected that way. We've done the analysis in the previous videos, and we've came up with the voltage gain being equal to V out over V in, and in terms of the resistances being used, it was equal to minus Rf over Ri. As you can see, it's a negative gain. It's a negative gain, which proves that it is the signal get inverted. So if you've got an input signal like that, let's say of a peak value of 1 volt on the input, you get on the output for a gain of, let's say, minus 4, you get an output signal with inverted polarity, amplified but also with inverted polarity. So you get the amplitude to be 4 times bigger but also inverted polarity. As you can see, we went from plus 1 volt to minus 4 volt, and when the input goes negative, that's when the output goes positive. So that's what justifies the negative sign there. And as we derived in the previous lesson, that comes from the fact that the current that flows on the input flows in that direction, while the current that flows on the output flows in the opposite direction. So we get two currents of the same value, but same magnitude, but opposite directions. And also due to the fact that VID is normally supposed to be 0, so there shouldn't be any voltage difference between the non-inverting input as well as the inverting input of the amplifier. That's what makes this point behave like a virtual ground. Right. That's just to revise what we've done already. Similarly, we've also touched on non-inverting amplifier configuration. Non-inverting amplifier configuration. And with the non-inverting amplifier configuration, the input is on the non-inverting pin, which is the positive pin. So in this case, we've got the negative pin, the input applied on the input is applied on the non-inverting input of the amplifier, which is the positive input. That way we've got the input signal Vi is applied there, and on the negative, that we've got the feedback configuration. We have V out, we've got Rf, and we've got R in, all grounded. On basis of the principle that the difference VID between the two input signals must be 0, then if Vi is applied on the non-inverting input or positive input, then the same amount of voltage will normally appear there. So there we're going to have Vi in order to satisfy that condition. And by voltage divider, we therefore have V out applied across Rf, then we get Vi there, the input voltage, and we've got R in, and then we'll ground. If you apply voltage divider rule, you get Vi to be equal to V out times Ri divided by Ri plus Rf, and this leads to Vout over Vi, which is the voltage gain, to be equal to Ri plus Rf over Ri, and that can be simplified in 1 plus Rf over Ri. But we've also